Hello students, today we will begin with an interesting topic in physics, which is motion. In today's class, we will be discussing only the theory. In the next video, we will be discussing about the numericals. So keep watching, and if you have not yet subscribed to the channel, do subscribe now so that you don't miss out on any new topics. With respect to the position of an object, the object can be said to be in a state of rest or in a state of motion. A body is said to be in a state of rest when its position does not change with respect to a reference point. And a body is said to be in motion when its position changes with respect to a stationary object taken as a reference point. Motion can be of many kinds. As you already know, motion can be in a linear motion, that is in a straight line. It can be circulatory or it can be oscillatory. Before we proceed any further, we need to know what is the meaning of a reference point or the origin. The reference point or the origin is a specific point about which the position of an object is defined. For this, we will look at an example. Let us take this tree to be the reference point. So with reference to the position of this tree, we can say that A is at a distance of 10 meters from the tree and B is at a distance of 5 meters from the tree. If there was no reference point, which is if there was no tree, then it would be difficult to say that A is at a distance of 10 meters or B is at a distance of 5 meters because we cannot say it with respect to what is it at this specific distance. In physics, we need to know what are physical quantities. Physical quantities or physical quantity is the physical property of a material that can be measured. Example, length, time, temperature. Length can be measured, time can be told. Now physical quantities can be of two types. We have the scalar quantity and we have the vector quantity. Scalar quantity is a physical quantity having only magnitude and not direction, which means we can express this quantity with the help of numbers and it is not dependent on direction. For example, length. It is easy to tell the length of a room or maybe the length of a string. It does not depend on the direction. Whereas a vector quantity is a physical quantity having both magnitude as well as direction. So velocity, acceleration, displacement, momentum, force, these are all examples of vector quantities. Let's take for example force. It is a physical quantity having both magnitude as well as direction. How much force is applied to the object so that it moves in a specific direction is going to be how we measure force. So we can say, okay, that there has been a force of 2 Newton which has been applied to this object so that it moves forward towards the east. So we are discussing both magnitude as well as direction in the case of force. Some of the physical quantities which we will be discussing in today's class: distance and displacement, speed and velocity, uniform and non-uniform motion, acceleration and equations of motion. So let us begin by discussing what is distance. Distance is the actual length of path traveled by an object irrespective of the direction in which the body travels. To understand this, let us look at this figure. We have the object which begins
from the initial point or the starting point, which is O. From O it travels to A, from A it goes to B, from B it goes to C, and from C it goes to D. So this becomes the actual length of path which is traveled by the object. Now if O is the starting point and D is the final point, then the total distance becomes the actual length of path which has been traveled by the object. So this becomes OA plus AB plus BC plus CD. So substituting the values which have been given here, we can find the distance that has been traveled by this object, which is 43 meters. Now if you look at this figure given here, you see that the object does not travel only in one direction. The direction is changing. So it is irrespective of the direction in which the object moves. It is the length of the path. So we know now that distance does not depend on direction. So what is displacement? Displacement is the shortest distance between the initial position and the final position. To understand this better, let us look at this figure. If O is the initial position and the object moves from O to A and from A to B, here O is the initial position and B is the final position. So to find the displacement, we have to take the shortest distance between the initial position and the final position, which is OB. Now if you look closely at this figure, this is a right angled triangle. So by using Pythagoras theorem, we can find the displacement OB, which is 5 centimeters. Now that we have discussed what is distance and what is displacement, let us look at some points of difference between these two. Distance is the actual path or length traveled by an object irrespective of the direction in which the body travels, whereas displacement is the shortest distance between initial point and the final point. Distance is a scalar quantity and displacement is a vector quantity. Scalar quantity is we take in account only the magnitude, whereas for in vector quantities we take in the magnitude as well as the direction. Distance will always be positive and cannot be zero, whereas displacement can be positive, negative and can be zero. Here are some points to remember. Displacement of a moving object can never be greater than the distance traveled by it. So displacement will always be less than or equal to distance. Displacement of an object can be positive, negative or zero, but distance can never be negative or zero. Now if a body moves along a straight line in one direction, then distance and displacement will be equal. Now let us look at this figure to understand when the displacement can be zero. If the initial position and the final position is the same, then displacement will be zero. So in this figure, O is the initial position, and let's say from O the object has traveled to A, from A it has traveled to B, and then from B it has traveled back to O. So the initial position and the final position becomes the same. So then displacement is zero. Displacement can also be zero if the object moves in a straight line and it moves from one point A to another point B. So let's say the object is moving from one point A and has gone to B, and then it has traveled back to A. So A, or this point, becomes the initial as well as the final position. So when a body moves in straight line motion from A to B and then goes back to A, then the displacement will be 0. Also, displacement can be 0 when the body moves along a circular path. So here, if we take this point to be the initial position and the body moves along this circular path, then it will come to the initial point and then the displacement will be 0. So I'll just show you again here. If this is the initial position and the body moves along the circular path and it comes back to the initial position, then displacement is 0. Okay? So let us discuss now what is meant by uniform motion and non-uniform motion. Uniform motion is when a body travels equal distance in equal intervals of time, and non-uniform motion is when a body travels unequal distance in equal intervals of time. To understand this, we'll look at this figure. If a body travels from A to B and it covers a distance of 5 meters in 2 minutes, and then it travels from B to C and again it travels 5 meters in 2 minutes, then that means this body is traveling equal distance in equal intervals of time. So if it is covering equal distances in equal intervals of time, then this body is moving with uniform motion. Whereas for non-uniform motion, you can look here, if the body has moved from A to B and covered 5 meters in 2 minutes, and then from B to C it has covered 10 meters in 2 minutes, then the distance is unequal. It has covered unequal distances in equal amounts of time. So this is an example of non-uniform motion. To understand this better, we will refer to the example which has been given in the NCERT textbook. So here is a table. It specifies the time taken by the object to travel a certain distance. So there are two objects, object A and object B. This is the time taken by the objects to cover the distance. Now if you look at this chart, you will see that here the time is equal, or there are equal time intervals from 9:30 to 9:45. There are 15 minutes. So there is an increase of 15 minutes here. So there is equal time intervals. Here the distance is equal. The body is traveling 10 meters and after 15 minutes it is traveling 20 meters. So that means it is 10 meters again. After 15 more minutes it is at 30 meters. So again it is 10 meters. And body B is traveling in unequal distances. So the question is, which body is traveling, or which body has uniform motion? Now if you remember the definition of uniform motion, the body has to cover equal distances in equal intervals of time. So that means that vehicle A will be traveling with uniform motion. Here we can see that every 15 minutes A is traveling 10 kilometers or 10 meters. Whereas in the case of B, the distance travel is irregular. Sometimes it is covering 7 meters in 15 minutes and in the next 15 minutes it is traveling 4 meters. So this is having what kind of motion? Non-uniform motion. Now do you remember what we said about non-uniform motion? We said if a body is traveling unequal distances in equal intervals of time, then it is having non-uniform motion. A body can also be said to have non-uniform motion when it covers equal distances in unequal intervals of time. So let's look at this example. If a body travels from point A to point B and it covers 10 meters in 3 minutes, and then from B to C it is covering again 10 meters in 4 minutes, and from C to D it is again covering 10 meters but it takes 6 minutes. So what is happening here? The body is covering equal distances in unequal intervals of time. So this is an example of non-uniform motion. This is what we had said previously. When a body covers unequal distances in equal amounts of time, it is having non-uniform motion. A body is said to have non-uniform motion also when a body covers equal distances in unequal intervals of time. What is speed? Speed is defined as the distance traveled by an object per unit time. The speed of an object is given by the symbol v, and its formula is speed of an object is equal to distance, which is denoted by s, upon time t. The SI unit of speed is meter per second. Now since the distance traveled by the object is either positive or 0, so the speed will also be positive or 0, but it will never be negative. Now we have discussed about what is uniform motion and non-uniform motion. Now let us look at what is meant by uniform speed and non-uniform speed. If a moving body covers equal distances in equal intervals of time, then the speed of the body is said to be uniform or constant. This body is moving with uniform speed. Non-uniform speed is when a moving body covers unequal distances in equal intervals of time. To understand this, we will look at these figures. So here we have an object which is moving from A to B. It covers 5 meters in 2 minutes. And then from B to C, again it is covering 5 meters in 2 minutes. So the body is covering equal distance in equal intervals of time. So the speed of the body is uniform or constant. Now for non-uniform speed, the body covers unequal distances in equal intervals of time. So you can see here that the body has covered 5 meters in the first shift up position. So here the body has covered 5 meters in 2 minutes, and then in the next 2 minutes the body has covered 10 meters. So it has covered unequal distances in equal intervals of time. Then the speed of the body, it will be non-uniform. This brings us to an interesting subtopic, which is average speed. Now how will we know what is the average speed of an object? The average speed of an object is defined as the ratio of the total distance traveled by a body to the total time taken. So average speed is equal to total distance traveled upon the total time taken. So let's say now this body has moved from A to B. It has covered 5 meters. Then from B to C, it has covered 10 meters. So the total distance will be 5 plus 10, which will be 15 meters. So also the total time taken. So from A to B, it took 2 minutes, and to reach from B to C, it took 2 minutes. So you add 2 plus 2, you will get the total time taken. This is for the average speed of the object, which is the total distance traveled upon the total time which is taken. So what is instantaneous speed? The speed of an object at any particular time or at a particular point of its path is called the instantaneous speed of the object. Now the speedometer, which is present on the vehicles, the speedometer measures the instantaneous speed of a moving body. It measures the speed at that particular time or at that particular point of its path. So at a certain point, the speedometer will tell you what is the speed at which you are traveling. So now that you know what is speed, let us discuss what is velocity. Velocity is speed with direction. It is the speed of an object moving in a definite direction. It is defined as the displacement of the body per unit time. It is expressed as velocity of an object v is equal to displacement upon time. The SI unit of velocity is meter per second. The velocity can be positive, negative or zero. Remember, velocity is a vector quantity and we need to take into account both magnitude and direction. Velocity can be uniform or it can be variable. Uniform velocity is if a body moves along a straight line or a straight path in a specific direction and it covers equal distance in equal intervals of time. To understand this, let us look at this illustration. If the body has moved from point A to B and from B to C and C to D, it covers equal distances in equal intervals of time, such that it is moving along a straight line path in a specific direction, that is towards the east, then this body is moving with uniform velocity. Now velocity can be variable. How can we change the velocity, or when will velocity be variable? Velocity of an object can be changed either by changing the speed of the body or by changing the direction but keeping the speed constant. So let's look at this example here. We have the body moving from A to B and then it is moving from B to C. Now if the body is moving from A to B and covers 5 meters in 2 seconds, what will be the speed of this object? Distance upon time. So 5 meter divided by 2 seconds is 2.5 meter per second. So this is the speed at which the body has traveled from A to B. Now from B to C, the body has covered 7 meters in 2 seconds. So the speed is distance upon time 7 divided by 2, which is 3.5 meters per second. So the body has different speeds, or there is a change in speed. So the velocity also will change. Now by changing the direction but keeping the speed constant, we can vary the velocity. So let's say that the body begins moving from this point. So if the body travels from point A and it goes along a circular path, then the body is moving with in a different directions. So you can see from here it is moving towards the west, then the south, then the east, and it comes back to the north. Okay, so the direction has been changing, but the speed at which the object travels is constant. So the velocity of the object can be changed either by changing the speed of the body or by changing the direction but keeping the speed constant. If an object moves along a straight line at a variable speed, then we can calculate the average velocity of that object. To calculate the average velocity of the object, we use the expression average velocity denoted by VAV, which is average velocity, is the total displacement upon the total time taken. The SI unit is meter per second. Now if the velocity of the object is changing at a uniform rate, then the average velocity is expressed as the arithmetic mean of the initial velocity and the final velocity. So the average velocity will be expressed in this way, the initial velocity plus the final velocity upon the time taken. So this will be u plus v upon 2. So for this you have to take the initial velocity as well as the final velocity and add the initial and final velocity and divide it by the total time which it takes. Now here are some points of difference and point of similarity too between speed and velocity. Speed is the distance traveled by a body per unit time, and it is given as distance upon time. The SI unit is meter per second. Velocity is the distance traveled by a body per unit time in a given direction. Velocity is given as displacement upon time. Its SI unit is also meter per second. Speed is a scalar quantity. We take into account only the magnitude, and velocity is a vector quantity. We take in magnitude as well as direction. Speed will always be positive. Velocity can be positive, negative, or can be zero. Now let us discuss what is acceleration. Acceleration is defined as the rate of change of velocity with respect to time. It is expressed as change in velocity upon time taken. Now if the velocity of an object changes from the initial value u to final value v in time t, then acceleration is expressed as a is equal to final velocity v minus the initial velocity u upon t. So the expression becomes a is equal to v minus u upon t. The SI unit of acceleration is meter per second square. Now from where did we get this final velocity and initial velocity? To understand that, let's look here. Now let's say the object has moved from A to B. If the object has moved from A to B, A will become its initial velocity. At A, its initial velocity was 0. But when it reached B, its final velocity was 4 meter per second. Now if we take B as the initial velocity of the object, then the body when it reaches C has a final velocity of 8 meters per second. So now to find the acceleration, we need to follow this rule. We have to subtract the initial velocity from the final velocity. So to find the acceleration in the first case, that is when it is moving from A to B, we take the final velocity, which is 4 minus 0, and what is the time? The time is 2 seconds. Correct? So this will become 2 meter per second square. Now how did you get second square here? Because this is meter per second divided by 2 seconds. So this second is taken on top, so you get meter per second square. Now if you take the position of the object moving from B to C, so we are taking now B as the initial velocity and we are taking C as the final velocity. So in this case, it will become the final velocity, which is 8 minus 4 divided by 4. So 8 minus 4 is what? 4 upon 4. So the acceleration will become 1 meter per second square. Okay, remember that we have to subtract the initial velocity from the final velocity to get the acceleration. Now that you know what is acceleration, let us discuss what is meant by uniform acceleration. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the object is said to be in uniform acceleration. For example, we can take the motion of a freely falling object. So if an object is thrown from a height, it will fall from the top to the bottom. So the line of motion is a straight line. Its velocity can increase or decrease in equal amounts of time. So it is having uniform acceleration. Also, the motion of a ball rolling down an inclined plane. So inclined plane is like a slope. So if the ball is rolling down the slope, it is moving along an inclined plane, which is also a line. Its velocity can increase or it can decrease. So when it is rolling down, of course, it will increase in equal intervals of time. So it is having uniform acceleration. So what is non-uniform acceleration? If the velocity of an object increases or decreases by unequal amounts in equal intervals of time, then the object is said to be in non-uniform acceleration. Examples are the movement of a car on a crowded road or the motion of a train entering or leaving the platform. Now, if you have ever been caught in a traffic jam on the road, you will understand this, that the velocity can increase or it can decrease by unequal amounts in equal intervals of time when you are stuck in a traffic jam. Also, the motion of a train entering or leaving the platform, it can either gain acceleration or there can be deceleration. The equations of motion are very important in this lesson, and a lot of the numericals will be solved using these equations of motion. Of course, we will also be using the expressions which we have discussed earlier. So please see that you learn your equations of motion because it will be helpful in solving the numericals. So let us see what is meant by equations of motion. The relationship between velocity, acceleration, and distance traveled by a body moving along a straight line with uniform acceleration in a particular time interval is expressed by a set of equations which are known as equations of motion. So basically, equations of motion relate velocity, acceleration, distance, and time. So here we have got the equations of motion. Before we go to the equations of motion, let us look at what each of these mean. U is the initial velocity, V is the final velocity, A is uniform acceleration of body, T is time in seconds, S is distance traveled. So let's look at the first equation of motion. V is equal to U plus AT. So this relationship is between velocity, acceleration, and time. So what is this actually a relationship between? When we say velocity, we have final velocity and initial velocity also here. So it is the final velocity. To find the final velocity, it is the relationship between the initial velocity, final velocity, acceleration, and time. To find the distance, when we know the initial velocity, time, and acceleration, then we use this expression S is equal to ut plus half at square. Next is the relationship between the final velocity, initial velocity, acceleration, and the distance traveled by the object. Well, students, in today's class, we have covered all the theory that we had to learn in this lesson, and in the next video, we will be solving the numericals which are based on the equations of motion and the other expressions. Till then, practice the concepts that we have covered in today's class. I'll see you soon with the next video on numericals. Thank you for watching. Till then, stay home, stay safe, and do practice whatever we have covered in today's class.